Good evening to all of you. I hope you are completely safe and healthy. So let me start the second part of your channel transition. So in my previous class, we have discussed channel transition. First two cases we have discussed, that is channel width reduction as well as channel width expansion. So in today's class, we'll discuss channel bottom rise and channel bottom fall. So we'll discuss these two. Okay. So let's start. Go to that case. Okay, so same thing, rise in channel bottom. First I will be taking subcritical, then I will be taking supercritical. So let me draw that first. The channel will be like this. As you can see, there is a rise. That rise distances, the rise height basically is delta Z. Now, if there is a change in the channel bottom, whether you will be able to find that in the top, a top diagram or plan view? No, because there is no change in the width. So width is same at both the section. Width is same at both the section. So B1 is equal to B2. B1 is equal to B2. So this is the Y1 depth. This is the Y1 depth. Okay. Clear? This is B1. This is B2. This is the Y1 depth. These things already given to you. Now what you need to find out is the Y2 depth. Whether Y2 is more than Y1 or less than Y1, that you need to find out. The first condition what we write generally, as you can see, B1, B2 are same. So small q1 is equal to q2. But as you can see here, there is a difference in channel bottom. So I can write the equation is like E1 is equal to E2 plus delta Z. That means E1 is greater than E2. Now you know that if there is a change in specific energy, we need to refer specific energy curve. So let me draw that specific energy curve for you. So this is the minimum point, or you can call it as a critical point. Here you are getting EC as a critical. This is the Y. Okay. Now look at my dear. If I want to plot E1 and E2, as it is a subcritical, I will be looking in the upper part. So let me plot that. So here it will be E1, as E1 is greater than E2, na? So E2 will be here and E1 will be here. If you want, you can plot these things. So here you are getting Y2, here you are getting Y1. That means what we got here, case first I am writing. If, or directly I can write it here now. If E1 is greater than E2, then what will happen? Y2 will be lesser than Y1. This is for the subcritical flow. And in the same case, if I will be looking for supercritical, what will happen here? See, look at my dear. This time E2 will be here and E1 will be here. So if you want to plot, you can see Y2 is more and Y1 is less. So Y2 is more compared to Y1 for supercritical. Always remember, whatever we are getting in subcritical, just opposite to that we will be getting in supercritical. Have you understood this part? First logic, whenever there is a difference in any quantity, you have to use that specific energy curve. You have to use that specific energy curve. Like that curve specifically, here specific energy difference is there, so we are using a specific energy curve. Okay. Now, this E1, E2, you need to plot it. First time I am plotting in a subcritical zone, and another time I am plotting in a supercritical zone. And for that, different things we are getting. Different things we are getting. Now look at the concept, second concept which I am telling you. As you can see, I have written the equation E1 is equal to E2 plus delta Z. Now what I am doing here, I am increasing this delta Z value. So let us say if I will be increasing up to something like a delta Z maximum. So in that case, what will happen? See, E1 cannot change. You cannot change the initial flow. So in that case, E2 has to go down. So E2, up to what point you can go down? Up EC. Below than critical specific energy, it is not possible, na? Because critical specific energy is the minimum of specific energy. So E2 can be lower down up to what point? Up to EC. And then it becomes E1. But now what happens? This delta Z we also call as delta Z critical sometime. So if somebody will ask you, I want the maximum height or maximum height of hump which is possible so that the initial flow does not get disturbed, or so that efflux does not caused. So in that case, actually they are searching for this delta Z maximum. In that case, you need to take E2 equal to EC and E2 equal to EC, and then you can find out delta Z critical. But what happens when you are giving delta Z more than delta Z maximum? This can also happen now. Like some mad guy will come, he will say, no, I want to give delta Z more than the critical value. Okay, give it. E2 EC. More than that you cannot do. Already E2 is at minimum level. More than that you are not allowed to do. EC. Then the only thing which need to change is the E1 part. And then E1 will be changed to E1 dash. That means what happens, my dear? Your E1 changed to E1 dash. That means your initial flow gets disturbed. That we never want. Your initial flow gets disturbed. Now look at, my dear. If E1 tends to E1 dash, as you know that definitely E1 dash will be more, na? For that, if you want to plot this E1 dash and E1 in specific energy curve, again you have option. Either you can go for the subcritical or supercritical. First time I am going in a subcritical, so it will be E1 dash. Here it will be E1 dash for supercritical. Plot again you need to plot it. So what we are finding there, what I am finding there, Y1 dash, this is Y1 dash. As you can see here, Y1 dash is more than Y1. This is for the subcritical zone. And Y1 dash is less than Y1 for supercritical zone. Have you understood this? Have you understood this? So this you need to understand, my dear, that if you are disturbing, if you are giving delta Z more than delta Z maximum, what will happen? Your initial flow will get disturbed, and this will be Y1 dash sub, if you are considering subcritical flow. Otherwise, if you are considering supercritical flow, it will be Y1 dash super. In a supercritical, it will be less than the previous one, Y1, original one, or in a subcritical, it will be more than the Y1. So this same thing you can understand. Is it clear? Completely clear? If these things are clear, then we can go to the numerical. If these things are clear, then we can go to the numerical part. See, if you understand channel bottom rise, channel bottom fall is the simple case. Nothing to worry about. Channel bottom fall is the simple case. Channel bottom fall is the simple case. I hope you guys have copied. I hope you all guys have copied. Okay. Now look at the next case. That is channel bottom fall. That case heading, we need to write it. No problem. Channel bottom fall. For that, I'm telling you, for subcritical, you guys can do it same for the supercritical. Now look at the case first of all. This is your channel. Suddenly it got fall down. If you see from the top, there will be no change in the width. So B1 and B2 are same. This is the initial depth which is given to you. As you can see here, this is the nothing but the delta Z. So I can write E1 plus delta Z is equal to E2. That means E2 is more than E1 here. Q1 is equal to Q2. As B1 is equal to B2, Q1 will be equal to Q2. So as there is a difference in specific energy, so I am referring a specific energy curve. You know this. These all concept I have told you in my yesterday class. So this is the EC value and this is the YC value. Now look at my dear. I need to plot this E2 even. Na? I need to plot this E2 even. E2 is more than E1, so E2 will be somewhere here and E1 will be somewhere here. You can see, my dear, Y2 is more than, for E2 greater than E1, Y2 is more than Y1. Y2 is more than Y1. Y2 is more than Y1. Just opposite of whatever you got in channel bottom rise. Just opposite you will get in channel bottom fall. So here you are getting Y2 more than Y1. Clear? Is that clear? Now here that the second part which we have discussed in the previous case. Na? In this case, it is not required to discuss that. Clear? So same thing you can do it for, like this you have got for what? For subcritical. If you plot this E1, E2 in a supercritical zone, you will get Y2 is lesser than Y1 for supercritical zone. So no need to. Is it clear? So if thing is that if you understand the concept now, all 8 cases will be easy for you. No need to mug up and all. If you are not getting the concept, then every case will be difficult for you to. Okay, note it down, then we'll go to the problem. We'll solve 2 problems based on this, and then our channel transition topic will be over. From Monday, I will be starting GVF, gradually varied flow. After that, hydraulic jump, then surges. Anyone having any doubt? Those who are watching live, anyone having any doubt? See, if you have doubt, you can ask. Otherwise, in problem, you will be in problem. So while solving problem, you will get too many difficulties. So if you are having any doubt about any cases, like right now, total 8 cases are over, na? 4 cases I have discussed in my yesterday class, 4 cases I have discussed today. So total 8 cases I have discussed. So out of 8 cases, if any cases you feel doubt, you can ask me. I will repeat that again. But you have to ask. Okay. So if this thing you have noted, then we can solve the problem. First problem for all of you. Let us see who are giving me the right result. A 3-meter wide rectangular channel. So B is 3 meter, which is given to you. Capital Q is 6. Depth of flow at a section P is 0.5. So Y1 is given to you. A flat topped hump is to be placed at the downstream of the section P. The assume negligible energy loss between section P and the hump. G is given to you. The maximum height of hump, which will not change the depth. So it's a case of channel bottom rise. First of all, it's a case of channel bottom rise. Like this. This is the delta Z. What they're asking you, they are asking delta Z maximum. So you know this condition. E1 is equal to E2 plus delta Z. Now, as you want delta Z to be delta Z maximum, this E2 becomes EC. So delta Z maximum will be actually equal to E1 minus E2. Sorry, E1 minus EC. Now we can calculate that. EC is what? 3 by 2 YC. It is a rectangular section, so 3 by 2 YC I can write. YC is what? Small q square upon G. G we have 9.81. Q we have 6. 6 divided by 3, it will be 2. 2 squared, it will be 4 to the power 1 by 3. You can calculate the EC part. Then E1 will be, we have depth, initial depth, we have 0.5 divided by V squared upon 2G. So 2 into 9.81. V square, that will Q square. So 6 square divided by 3 into 0.5 whole square. That is V square. So E1 and EC, that you guys can calculate and tell me.